Hey folks, welcome to the Dark Horse Podcast live stream number 340, if you can believe that. I'm Dr. Bret Weinstein. I'm of course sitting with Dr. Heather Hying. Interesting mix of topics on the way today. We obviously have a developing story in Tibet and Nepal with what's being described as a flash flood. That terminology does not really evoke the right thing for this disaster, which we will talk a bit about.
And we're going to talk about some recently published research addressing the question of climate change, and also some recently published research on the question of how female frogs choose their mates and what gets in their way. And there is actually a common theme between these three stories, which is the nature of evidence. Like what constitutes evidence? How, it's an epistemological question. On what basis are we making claims of knowledge, of truth? And sort of when can you trust your own eyes? How for two of these stories, it's a question of historical inference. So historical science is different from most of the science that people think of when they imagine up science. But of course, we are engaged in thinking about historical science, and both with regard to a flood that is happening right now, but has many of the hallmarks of past floods for which we can only infer what happened. And of course, with regard to climate change, the idea that the climate is changing requires that you have some sense of what it used to look like. So how do we make inferences from the past? And that's some of what we'll be talking about today.
Yeah, it's especially interesting in light of the fact that we have historical patterns, we have modern examples of things that are in some ways like them, and we also have radically changing technology. So even over the course of our lifetimes, where there's evidence for all of the things that have taken place, the nature of that evidence varies radically, even at this point now, year to year.
Yes. And, there's been much psychological research showing that eyewitness accounts are not inherently reliable. But obviously, your eyes will be more reliable at telling you what you have seen than going through someone else's eyes. Even if that someone else was standing near you at the same time, your eyes are more reliable. And your eyes are more reliable than using a tool to infer what you have seen, unless it's impossible, because the scale is outside of the potential for human experience. So, we live in an era when technology mediates almost all of what we think we know, and it is therefore more important than ever to consider what the nature of evidence is.
Yeah, almost everything that we are talking about online that people are fascinated by is a question of what constitutes evidence, how you evaluate that evidence, and what one naturally extrapolates from the evidence that they've decided is reliable enough to include.
Indeed. All right, so we're here today. We'll be here next week. We're not doing a Q&A today, but we had one so recently. I feel like it was last Sunday, was it?
I think it
was. So you can go and check out all of our past Q&As on Locals, and we always do watch parties during live streams. So join us there, and let's just start at the top of the hour as we always do with our three sponsors, and then get into the meat of the show.
Heather, our first sponsor this week is Ethos, which connects people to life insurance. There are a lot of reasons to seek life insurance. I would put death at the top of that list.
But by then it's too late.
Yes, by then, well said, exactly. So the reasons that people do this involve the fact that you're becoming a new parent or buying a home or just want to protect your family against the financial burden that could follow an unfathomable loss. We've looked for life insurance in the past and have been disappointed by what's out there. Insurance is a mess, and it's hard to know where to start. Ethos can help. Ethos helps provide financial security by connecting people with life insurance carriers fast and efficiently. Ethos makes getting life insurance fast and easy. It's 100% online. There are no medical exams. You just answer a few health questions online, and there you go. You can get a quote in seconds, apply in minutes, and even get same-day coverage. Up to $3 million in coverage is available, and rates are good, very good. You'll get the lowest rate possible for you from the Ethos network of trusted carriers. Ethos has 4.8 out of 5 stars on Trustpilot and over 4,000 reviews. So take 10 minutes to get covered today with life insurance through Ethos. Get your free quote, not croat, that's what some frogs say, not all of them.
Not all of them.
Get your free quote at ethos.com/darkhorse. That's ethos.com/darkhorse. Application times may vary, rates may vary. Trustpilot rating as of 6/1/2025. Once more, that's ethos.com/darkhorse.
Awesome. Our second sponsor this week is, well, do you want to guess?
Yes.
I don't think you should guess.
No, okay, I'm not guessing.
Yeah. I mean, you could, but only if you were going to choose something totally absurd and not within our usual suite of sponsors.
I would not do that, but yes. I'm not going to bet a lot, but I'm going to bet it's Bentley.
Bentley.
Yes.
Yeah. They gave us a, well, they didn't actually. Okay. Yeah, they've never approached us.
Keychain.
And we're good. We don't need a Bentley.
No. I don't even really want a Bentley. It's
right.
Just, if you're going to pick a car name, that one is sort of funny.
It is.
Bentley.
Yeah. It seems like it must come with a chauffeur.
It sort of sounds like a Kia, but it's the opposite.
Yeah, I'm not equipped to have that discussion, but I have heard from individuals whom I trust that Kia is not what it used to be, and it is not just the bargain basement brand that it has.
No, I don't mean Kia in the sort of Yugo sense. I mean Kia in the sense of, a practical get it done car versus a.
But they're moving into some kind of different market now. Again, this is not a place that I am.
We will find out where Bentley is moving in this ad read.
We will not.
We will not. Okay.
Our second sponsor this week is not Bentley. Much better fit for us and for our audience. I am certain our second sponsor this week is Caraway, which makes high-quality, non-toxic cookware and bakeware. Whether you're spending time at the grill, the stove, or the oven, Caraway has the gear for you. Roast chicken in Caraway's cookware makes a summery cocktail with their bar set, or bake a seasonal berry crisp in their bakeware. If you're going to mix a summery cocktail with their bar set, better get on that, because summer is waning.
Oh, I thought you meant summary as in a cocktail that summarizes cocktails, which would be pretty cool, I think.
It would be terrible.
No, I think.
Oh, you're what do you mean? I'm imagining like a mixture of all the cocktails. Like, you want a margarita and old fashioned? Just have this. It's an old margarita.
No, I mean summary cocktail, like summary judgment.
Yes, but what does it mean for cocktails?
Well, I don't know.
Okay. I think we're done. A summery cocktail with their bar set, but do that soon because summer is waning. Or bake a seasonal berry crisp in their bakeware. That's Caraway's bakeware. Having beautiful and functional cookware, bakeware, and other kitchen essentials in your kitchen helps maintain visual calm, which is awesome no matter the season. Caraway has everything from mixing bowl sets and cutting boards to muffin tins and big pots on which to braise a piece of meat or make a long simmered stew. See, that's our segue into fall right there. Braised meats and long simmered stews. Not so much a summer thing as a fall and winter.
And a summer wane, which you mentioned. Climatologically speaking, it's waning.
Yeah.
At the end of summer.
Okay.
Yeah. All
right. Caraway Kitchen is crafted with FSC certified birchwood premius. Sorry, Caraway. We love your stuff. We really do. This is not about you. This is about us. It's our problem. With FSC certified birchwood, premium stainless steel.
Sounds like a Roman general.
Premius.
Yes.
And do you think that Premius, the Roman general, would have used Caraway had he the option? No, he wouldn't have, because he probably wasn't cooking for himself. But do you think his coterie of serfs and minions and such, they probably would have? I would say so. So Premius, the Roman general, used Caraway, which crafts their materials with FSC certified birchwood, premium stainless steel, enameled cast iron, and naturally slick ceramic. They make several lines of cookware and bakeware. Our favorites are their stainless steel line and their enameled cast iron, which is offered in 6 stylish and beautiful colors. These pots are strong and highly scratch resistant. They'll last generations. We're cooking with Caraway, and so is Zach, our elder son, in his college apartment. He says it's amazing, which we know to be true, and we know that he'll be cooking with it for a long time to come. Right now, you can save up to $230 on the 12-piece cookware set versus buying the products individually. Plus, if you want to include their fan-favorite Minis Duo, you can save up to $350. Visit carawayhome.com/dhpod to take an additional 10% off using code DARKHORSE on your next purchase. This deal is exclusive for our listeners, so visit carawayhome.com/dhpod or use code DHPOD at checkout.
And tell them Premius sent you.
And tell them Premius sent you. And Dark Horse.
Yes.
Who is apparently, Premius is now in our employ.
Premius may have ridden a dark horse.
He might have.
Yes.
Yeah.
Discerning as he was. Yeah, was.
Before he was in need of Ethos
He
to help him get life insurance.
Yes, he was waned out of the battle. I don't know. It's a thought.
It is a thought, yes. Our final sponsor for this episode is Puori. It's Puori, Puori. Puori makes a wide array of supplements and powders from vitamin C and magnesium to creatine and protein powders. It still says powers there, protein powers. What makes Puori? I haven't fixed that. What makes Puori different?
It's in the ballpark.
Yes, so is Previous, though. It doesn't make it right.
No, Premius is ridiculous. Protein powers, actin, myosin, it all makes sense.
Yeah, but they're selling powders. They're not selling straight up actin.
I'm just saying, it's directionally correct, as the kids like to say.
They don't say that.
Some of them do.
Do they?
Yeah, some of the more discerning kids. I think so. Well, by kids, I mean people in their 40s.
What makes Puori different is how clean and pure all of their products are. All of them. Let's focus on Puori's grass-fed whey protein powder, which was named Best Overall by Vogue US and Cleanest Protein by Wired. Our 20-year-old son, Toby, agrees. He's been making protein-enriched smoothies for a few years now, but had a hard time finding a protein powder that he liked. Of Puori's protein powder, he says, "This is the best of all the ones I've tried. It's smooth going down and full of great whey protein." Puori's grass-fed whey protein powder is not just nutritious, it's clean. A significant fraction of protein powders on the market contain lead in amounts that are known to be dangerous. In comparison, Puori consistently meets California Prop 65 standards and is Clean Label Project certified. Puori's protein powder also delivers a whopping 21 grams of whey protein in each serving and is free of GMOs, pesticides, and exogenous hormones. Whether you're looking for magnesium or a multivitamin, collagen, or protein powder, you can't go wrong with Puori. Can't go wrong with paper, however. Use code DARKHORSE at Puori.com/darkhorse to get 32% off your first Puori grass-fed whey protein order when you start a subscription. In addition, you get a free premium shaker bottle on your first subscription order. Go to Puori.com/darkhorse or use the code on the screen and use the code DARKHORSE at checkout for this limited offer.
All right.
That was worse than usual.
It was worse than usual.
Any way the fault of our amazing sponsors.
No, it's the fault in part of paper, which is kind of a fail that we are still stuck with paper.
Wrong.
I knew you'd say that, but at some level, you remember the slogan of Dunder Mifflin?
No, so Dunder Mifflin is the outfit in the American version of The Office.
Yeah.
Yes.
It was infinite paper for a paperless world. I kind of feel like we're just stuck in that slogan.
So you feel okay having everything be electronic when anyone at any moment can go in and be like, changed it for you?
No, I don't.
You don't have any record of that. You don't know what it used to say, do you?
I'm not arguing against paper. I'm just...
You totally just did. You totally just argued against paper.
All right, I am arguing against paper. I'm not arguing from the perspective of modernity, where we've actually landed that paper is now precious and becoming more so by virtue of the fact that stuff on it can't be changed, and therefore it's going to be our only reliable access to what has actually taken place. However, it's a very inefficient way of dealing with stuff, and the fact that we have not solved the problems of the electronic environment such that we are still, chopping up trees and using dioxin to make this very flat surface.
There is some stuff that is still often done on paper that shouldn't be done on paper if you can assure yourself that you have a stable version of it. Mm-hmm. So I would say bank statements, utility bills, these sorts of things are perfect examples where, as long as you have in a stable place on your own electronic drive somewhere that someone else can't access, copies of the records that are meaningful to you for your own life and finances, then there's no reason to be receiving those things in the mail. It is a waste of resource and time. Totally agreed, right? And labor on the part of people getting it to you. But books exist in paper form in a way that can't be changed, and B, I would say, and I didn't know we would be having this conversation, but I believe that there is research to back up my strong suspicion that I've had for a very long time, that reading things on paper impacts you in a different way than reading things online. Just as it is now coming to be understood that when you hear material, it enters your brain and tends to enter it in a more temporary way than when you read it. Reading on paper also has a more, it's literally more tangible. And, you know, I wonder for myself to what degree I'm just sort of, you know, dinosaured in that, that I grew up with paper, even though we had computers in my house much earlier than most people did, because my computer was a father scientist. That's not how that goes. No. My father was a computer engineer, computer scientist. But we also had walls and walls and walls of books, and he was also the opposite of an early adopter, even as like we had computers because that was his thing. He did not embrace the changes in technology until he was quite confident that what was being discarded was actually ready to be discarded and was not a better thing than the new thing on the horizon, which often what we already had was better, right?
Well, I would concede at the level of books of consequence. Books of consequence on paper makes sense to me. Everything else, I think it's sort of a mark of shame that we are still dealing in paper, and because paper ends up being superior in spite of the fact that, you know, the problems are solvable. But
so I disagree, as you know. I find that I edit better on paper than on a screen. I can make notes to myself that if I have a document, I mean, you've seen me doing this. I print out chapters and I edit, and then I go back through and make my edits. But if you're editing on screen, you feel like, oh, I have to do like everything I see I have to do right now, as opposed to I'm going to read this through. Like you have a document that remains stable, even as you can mark it up and know that what you had thought is going to be recoverable. And yes, I know there are ways to do this electronically, but they're not the same.
Oh, I'm
and leaving notes, actually physical notes, both to yourself and to others, and being able to put, you know, in the morning a note to you, or you to me, that it turns out our animals are feds, which is an important thing to know.
It's an ugly discovery.
It's an ugly discovery, but you're better off knowing it.
Yeah.
So I don't know actually how that started, if it was an intentional joke or if one of us wrote a note in which there was a squiggle that looked like an S after fed. But now whenever we have fed the animals and the other one isn't up yet, and we note that the animals are fed, so we've discovered it again.
Yep. Well, I'm obviously using paper, even though.
Yeah, this is a strange place to be having this conversation, because I never use paper here.
Yeah.
Why would I? Right. and here you use paper, and you would say like, well, this works better for me.
No, it works terribly, but better than any alternative I've come up with, though I've tried.
I didn't say you thought it was a great solution. I said it works better for you, which it must, because that's what you're doing.
Yeah. It sets a very low bar for sure. But okay, maybe we should dispense with the question of paper in a paperless world and move on to Nepal and Tibet. Okay, so what most of you will already be aware of is that there's been a terrible disaster in the mountains of Nepal and Tibet on the border. And the nature of that disaster actually appears to be changing. As it was originally reported this morning, there had been an earthquake. I think it was thought to be a 5.5 earthquake or less that had triggered the collapse of a glacier that had then blocked a river, and then that dam had quickly become unstable, and when it broke, this terrible torrent of water flowed down the watershed and obliterated communities that had been built there, because this is not a common event. Turns out that the current report, maybe this will be revised again, but the current report is that actually there was no earthquake, that in fact it was the collapse of the glacier that caused an earthquake, that basically this was such a catastrophic collapse that it shook the earth in the process of destabilizing and filling the valley with debris. So let's take a look.
Is there a suggestion as to why the glacier collapsed now?
No, I mean, I think it's going to be the typical thing where you have every conceivable factor, freeze thaw cycles, precipitation that has caused this layer to not adhere as well to that layer. So
tiny cracks that become big cracks that become catastrophic.
yeah, it's going to be some version of the story that causes avalanches in the backcountry because something is not as stable as it might be, and some, there's some straw that broke the camel's back where some fiber that holds something gives way and you get a positive feedback. So let's take a look at some video of what has unfolded in this watershed. Here we have this very substantial building. You see people are fleeing from it as the water careens and overtops the building, overwhelms the people.
How, so that was like a security camera or something? Like that was not a handheld camera, given what just happened.
Correct. And the camera looks like barely escaped. So just impossible amounts of water and debris flowing down this valley. And of course,
Yeah, it doesn't, honestly, it doesn't really look like water. It looks like debris mostly. But
well, and that's one of the things I wanted to surface in this, is that many of these types of disasters that are related, that we're going to talk about here, involve water, but water is not the thing with which we have experience, sometimes terrifying experience. Those of us who've spent time in the surf have often confronted, waves that knocked us over and caused us to momentarily feel like we were about to drown and things like that. But the point is, it's actually water. What happens when you have this much kinetic energy is that the water gets mixed up with stuff.
It scours the landscape and brings what it scours downslope with it.
Right. And so, there's this statistic when it comes to tsunamis, which we will come back to here in a moment, which is that only 10% of the people who get wet survive. I don't know if that's a reliable statistic. I don't know how much it changes with each major tsunami that happens, but if that statistic was ever reliable, it tells you something, which is you would imagine that a lot of people would get wet and climb a tree and be lucky enough to survive. And it happens less than you'd think, because once the water has gotten to you, it's full of stuff that tears you up, broken glass, floating metal roofs that have become sharp, nails on pieces of wood.
Well, and it's very rare that the water gets to you. You're at the water's edge when it gets to you, and you remain at the water's edge. Like you're at the water's edge when it hits you, but it is, for almost everyone that it encounters, continuing on. And so you are then part of a surge, as opposed to, at the tidal edge where you can sort of run back and forth and play with the waves. That's not how a flood or a tsunami works.
Absolutely not. But what you would imagine would be true is, tsunamis are sometimes terrifyingly fast. Mm-hmm. There are other cases, lots of the Boxing Day tsunami videos that came out of Banda Aceh and Thailand and various other places showed a relatively slow advance, with people actively getting out of the way. And, many of them did. But the point is, if even a slow advancing one, if it touches you, the chances that something befalls you that doesn't allow you to escape is exceedingly high.
Yeah.
Okay, can we show another video or two of this disaster? So here you have a very elevated view of after the ice dam has broken, the water from a river has built up behind it, the dam has then collapsed, and you have just tremendous amounts of dirt and water careening down this river valley. And you have structures, houses that have been built, not right on the shore, because of course rivers rise and fall and exceed their banks. But this is telling you something about how rare an event like this is, that you have this community that's built there. Obviously, communities in Tibet and Nepal have ancient roots, so people will know if this happens every 100 years and will think about it in building where they do. But in this case, the expectation was not there. Okay, now we're watching some workers had been working below a dam, a concrete dam. They had an excavator. People up on the cliff are yelling down to them to get out of the way. The guy in the excavator is trying to drive. He decides he's not going to outrun it, and so he abandons the excavator, and the water overwhelms them anyway. Here we have another elevated shot, and here you see people on motorbikes trying to drive out of the path of the water. They're basically keeping pace with it,
I don't see anyone on a motorbike.
You don't?
No,
Well, maybe they're running.
I see people running.
Yeah, okay. Still, they're keeping pace with it. They're not escaping it, but it's chasing them down the valley. Let's see. Oh, here we have a high up view of the water rushing away from the camera. In some other views that we're going to see, here we have people going to higher ground, which is, of course, the smart thing to do in this case. Now, no doubt everybody who tried to escape this will have attempted to get to higher ground, but it's not always possible to do that. There isn't always a trail or a staircase or something.
Although, a couple of scenes ago, we saw those people running that you took to be people on motorbikes. A couple of people who veered off and came upslope towards the camera, and most of them just continued to run down. And I imagine, even though the logical brain understands that you're better off higher up than lower down if what you're running from is water, it's still very hard, I think, in the moment to make a decision to do something that is more difficult right now.
Yeah.
Running uphill is inherently harder than, running up a steep hill is harder than running down a shallow slope.
I think there's confusion. There's also really terrible information. You don't know what's happening. And so if you know that something is coming and people are running away from it, you don't really understand what it is till it's too late. Here we have a picture of more apartments that are on the shore of a river. There's a steel frame bridge across the river. The river is now flowing so fast that it's eroding the supports of the bridge, and the bridge is going to collapse here. The water's now overtopping the bridge. It takes the bridge out with it. So now if you think about everything downstream, and, pieces of a bridge are now part of this slurry, we see the slurry, the mudslides often associated with volcanic eruptions, terrifying mudslides that are also have this sort of slurry characteristic. Okay, so what I was noticing and thinking about this disaster is that I've never seen one like it, but I've seen many things that have a component like this. One thing that came to mind was something that we don't know that any human being actually saw it. They may well have. But what we see is the aftermath in the scablands of eastern Washington. So we have just one photo here of something, the most major feature in the scablands of eastern Washington, which is called Dry Falls. Dry Falls is someplace our family has spent a ton of time with students when we were professors. It's a great habitat. It's like a mini Grand Canyon. You can walk around it, and there are trails, but you can depart from them and find interesting things. Anyway, what you're looking at here, this wall, is the wall of this feature called Dry Falls. And in fact, Dry Falls is not entirely captured in that photograph. Dry Falls is understood to be the largest waterfall that ever flowed on the face of the earth. It is now dry. There's water below it, which collects as lakes in the plunge pool. So when you have a waterfall like Niagara Falls, it digs out, it erodes the place right below the waterfall and creates a basin which can collect water. So here you have these permanent lakes on a permanently dry waterfall that when it flowed, I believe it was 20 times the flow, may have been 11 times the flow of Niagara Falls, greater than the flow of all the world's rivers combined. And it was a paradox because it's obviously a waterfall. Geologists can spot it as one, but there's no source of water. And so there was a battle in geology over the course of the 20th century. The hero of the story is a geologist named J. Harlan Bretz, who concluded that many of the features in the Scablands were the result not of a gradual process, the way something like the Grand Canyon was formed, and as was fashionable to think about in geology at that time. They had discovered how long the history of the Earth was, and they thought anything that sounds like a catastrophe is biblical religious thinking. All of these things are slow processes, and so they had concluded that the Scablands were formed by a gradual erosion.
Can I just add and just punctuate that point that this is often the way of science, that we can look back on dominant ways of thinking in particular scientific fields and say, yes, they had believed something too completely with too much certainty, and then they came to understand a point that could be understood to be the opposite. But instead of mitigating, instead of saying, as geology is coming to now, there are catastrophes and there are gradual processes, and very often we will see something that is explained by one or the other, and sometimes by both. But because geology was emerging from this era of catastrophism, which was often tied up with biblical religious explanations of the world, many moderns in the early 20th century in geology felt that we are past that, we are not a religious people, therefore catastrophes don't happen. And that is that's a logical error right there, but that does explain what happened with regard to our understanding of dry falls, and that, with the details changed, explains a lot of what happens throughout medical and scientific history.
Yeah, you get these sort of reactionary movements.
Yeah.
You fall in love with the last discovery you made, and it wipes out the nuance. So it's probably worth saying, since we're ultimately going to be talking here about the nature of evidence and historical science, that during this battle over what happened in the Scablands of eastern Washington, including Dry Falls, J. Harlan Bretz, the geologist who figured it out, had noticed all of these features of the Scablands that could not be explained by glaciation or gradual erosion. Not glaciation because the glaciers had never gotten to the Scablands, and not gradual erosion because the features were like river features scaled up 100 times. It didn't make sense that they were formed gradually by normal processes. So he knew that there had been a absolutely gigantic flood. There was a conference set up by his colleagues in geology effectively to ambush him, in which he would present his work, and then all of his colleagues who thought he was a crazed maniac would deride him, challenge him, etc. There is a famous story from that conference. The story is that Bretz presented, I think this is 1922, Bretz presents his paper, his argument for why all of the features that these geologists have miscategorized are actually better explained by a giant flood that nobody has spotted. And there is another geologist in the room at the conference, a guy named Pardee.
But Bretz, while on the stage, is asked, yeah, but where'd the water come from?
Right. He is asked, where'd the water come from? And Pardee does not put up his hand. What he does is he leans over to the person next to him and he says, I know where the water came from.
But Bretz didn't. So he's asked publicly where'd the water come from and unable to answer the question. And this is, again, a common error in scientific thinking. If you don't have the entire story, you must have none of the story. And that, of course, is very often not true. We are not required to know every piece of a model that we are working on for it to be a viable model. In this case, Bretz didn't know where the water came from. He knew that he didn't know where the water came from, and he was honest about that, and so he was laughed at. But in the audience...
Pardee says to this other guy, I know where the water came from, but doesn't pipe up for decades. And so Bretz is left with the embarrassing fact that he doesn't know where the water comes from, which, as Heather points out, shouldn't be embarrassing. The answer is, actually, I don't know where the water came from. Shouldn't we study that?
Yeah.
Isn't that the next question to answer, rather than, because you can't answer every question, the things that you can answer aren't real? So, point being, the ultimate explanation for the flood was even more remarkable than Bret had imagined. He imagined a single flood. In fact, what he had discovered was a geological quirk that caused repeated floods, massive, exactly as he had imagined them. You know, we're talking a wall of water moving at 60 miles an hour, 100 feet high. It, you know, went from dry falls to largest waterfall on Earth in the blink of an eye. There was nothing gradual about this process. The source of the water was a lake that we now know built up in Montana. We call it Glacial Lake Missoula. And it builds up because a finger of glacier reaches down from the poles during glaciation and blocks the Clark Fork River. As the Clark Fork River is blocked, all the water that would be flowing down into the Pacific down the Clark Fork builds up where Missoula, Montana is, and creates a lake the size of a modern Great Lake, a giant lake 1,000 feet deep. But a wall of ice is not stable. There are features of the physics of water that undermine the dam. So as you all know, water is special because when it freezes, it expands. That means that it can get below freezing temperature at the bottom of a lake where the pressure is high. There's no room for it to expand, so it doesn't. You get supercooled water, which works its way into cracks in the dam, and as soon as the dam becomes unstable, it literally explodes. And eastern Washington is washed over by the emptying of a Great Lake over the space of a couple of weeks.
Western Montana through Idaho, through eastern Washington, down into forming what is now the Columbia River Gorge, and leaving the detritus that will become the incredibly fertile Willamette Valley before flowing out to sea,
Yep.
the Pacific Ocean.
Stripping eastern Washington down to rock, depositing debris in the Willamette Valley, and depositing debris off at the end of the Columbia River at the coast in
Near Astoria,
on the continental shelf. You can see it now that we have the ability to use sonar to look at the seafloor. You can see this whole thing. So the Columbia River Gorge is formed by this event. The reason for those steep walls is that this water is careening down, kind of like what you see in Tibet there. But the point is, you had, in the space of hours, I think it's hours in Tibet, you had the forming of a dam and the building up of water. Maybe it was days, but over a very short period of time, you had the creation of a small lake, but analogous to Glacial Lake Missoula. And you had the bursting of that dam for reasons that were probably less dramatic, but nonetheless, you've got an unstable collection of ice and stuff, and you've got pressure building up behind it, and you've got people living in the valley, in the watershed below. And so this is like a mini version of this story that literally raged over all of 20th century geology.
and the repeated flood events that created dry falls in the Columbia River Gorge and the fertility of the Willamette River Valley occurred before any Europeans ever set foot in the New World. But presumably there were eyes on it. Presumably there were people who saw this at least sometimes. And it's not written down. These weren't people who were writing things down, but there were human eyes who saw it. But because most of them were lost, and all of what they saw is lost to history, all we can do is infer.
Yeah, all we can do is infer. Presumably, you can imagine, were you one of the natives that witnessed this event and survived to tell the tale, that it would defy normal explanation because it was not a normal event, right? And so the point is, you would hand down a story of an unthinkable flood without a natural conceivable cause, right? You would I'm just telling you that the water showed up out of nowhere and made a sound like a jet engine, and suddenly this valley was the biggest river that's conceivable and a lake, and that's what happened, right? And obviously the gods were displeased or something, so you can imagine that an extraordinary event would of course be recorded by people who just simply needed to pass it on.
Yes.
Right. This is something that happens, and this is what it looked like. And of course, if you didn't have, if you had those myths, if they had been written down and you were evaluating them, not from the point of view of 2026, but, from the point of view of 1826, then the point is, these people, they were a primitive people, and they had stories of terrifying gods and, events that didn't happen, but, galvanized their society. You'd say some bullshit.
Well, in 1826, someone who was being very careful and honest with themselves might have recognized that the sort of catastrophic story that would have been told was not unlike some of the catastrophic stories emerging from the Bible.
Right. So we have a much larger scale of a similar kind of event that exists in geology, and it's not the only one of those stories. There are other stories like that. This is our favorite because we know it best, and we spent a lot of time in that landscape. But the idea that a glacial finger blocks a river, creates a dam, the dam is unstable, and there's even one right now. If I'd thought of it, I would have dug up some video. There's one of these happening in Iceland. There's nobody in the way of it, but a glacial finger blocked a water course, and the thing destabilized. It was predicted to destabilize, and then I believe it did. You have two very different scales. One of them, in the mountains, the other in the plains of Washington, but they have this connection, right? The breaking of an ice dam that releases an unthinkable amount of water. And then we have, as we mentioned before, tsunami examples, which actually in many ways look a lot like this event. This event is described as a flash flood. Now, the problem is flash floods, you and I have seen one up close, nearly killed us. We were saved by a guy who knew it was coming and warned us not to go down to the spot where we had been swimming every day.
It's the story that we begin the introduction of A Hunter-Gatherer's Guide with.
And in that case, we were on this river in Sarapiquí, Costa Rica, where swimming was good. There was a little beach. And what we were not paying attention to, even though we grew up in Southern California where flash floods are a thing, was that it was raining in the mountains, not especially close, right? Yep. Probably 50 miles off. There was a torrential rain in a watershed that concentrated water and caused, trees that had fallen into the river to make dams that, would similarly burst. And so we stood on this bridge where the guy stopped us from going down, and we watched the water rise. I don't remember how long it took, but it came
not long
up probably 15 to 20 feet in minutes.
Almost to the level of the bridge. The bridge in this case did not go out, but giant trees coming down and being sucked into whirlpools that were created by this amazing amount of water, then being thrown into the air after they afterwards
popped back up out of the water.
Yeah.
It is really something. But the point is, flash flood, when you say flash flood, what you typically mean is there's a watershed that concentrates water in a way that defies normal experience. So you do not imagine that this arroyo is suddenly going to be flowing with enough water that you won't be able to stay with your head above, right? It seems like it's a trickle. It's dry out, and you're not thinking of the thing that's concentrating the water outside of your view.
Yeah.
And so you get caught off guard. That's not really what happened here. There's part of that story that's accurate, but it wasn't precipitation. It was water buildup behind a dam. And then the part that is similar to a flash flood is the way that a watershed concentrates the flow of water so that everything that happens over here ends up in this one little, low spot. And anybody who's anywhere near the low spot is caught off guard.
I guess just a semantic question. I'm surprised that you object to the characterization of this as a flash flood. To me, flash flood refers exactly to what happens as a watershed overflows its usual levels. It does not specify what caused that. And so you've identified two very different causes of flash floods, one from rain, one from a dam breaking. But they both result in, exactly as we've been talking about, the flood downstream.
I think I'm not disagreeing. There's a way in which this is a flash flood. There's a way in which this is a mountain tsunami. There's a way in which this is whatever, a mega flood of the sort that happened in Dry Falls. I'm not particularly concerned about the terminology. What causes me to think, when I heard that there had been a flash flood, I knew what I was looking for when I went to look at the videos, and that's not what I saw.
What were you looking for?
What a flash flood looks like, which does not involve people having built their homes, apartment buildings 5 stories tall in the path of it, because since the cause of a flash flood is typically
it's a like weather versus climate. It's a time scale issue that when it comes from rain in the mountains, everyone who's building there has lived there long enough, who has any sort of sense about them at all, knows more or less where they should and should not build.
100%. The idea that, look, rain varies. Years, there's a bell curve to the precipitation in a year. You've got some very light years. You've got some very heavy years. When you have a very heavy year, the ground saturates, and this particular watercourse can flood up to here. These people got caught off guard, even though this was their native habitat, and all of the things upstream from them exist all the time. And the point is, it was a rare confluence of things that caused this event to unfold this way. So flash flood, let's put it this way. The thing that caused J. Harlan Bretz not to be able to make his case to his fellow geologists was that they could not see the scale of the features he was pointing to. They were 100 times too big. So a pothole that would be a foot across in the bottom of a river was 100 feet across. And so it doesn't look like a pothole because you think of a pothole as a 1 foot across thing. One of the things that cracked the case for Bretz was aerial photography, which was brand new. There were no planes until, the Wright brothers succeeded in flying for the first time in 1903. So the idea that there were enough planes to take aerial photography, that had to wait. But once you did have people in airplanes, you could see that the hills in Idaho were actually ripples on the floor of a river that would have to be unlike any river that anyone has ever seen in order to account for them. So what I'm seeing here is a flash flood at the wrong scale. And it's that same thing. Yes, it's a flash flood, just as, the flood that created the Scablands and the Columbia River Gorge was a flood. But flood does not, we've all seen floods. This is a flood plus a scale phenomenon that defies every expectation that you would normally have. And actually, let's look at the Japanese. This is a 2011 Fukushima prefecture had a earthquake that then quickly caused a tsunami. The tsunami then caused a triple meltdown at the nuclear reactor. Never mind that. Let's just look at the tsunami part of it. No, that's from Peru. The video of the boats being washed inland. There's a seawall that's actually supposed to be protecting from tsunamis, but this particular tsunami is too large, overwhelms the protection. The boats have become unmoored. These are seafaring people. They know how to handle boats, and tsunamis are a well-known phenomenon, but all of their preparations are overwhelmed here, and the ocean just washes inland, tears buildings apart, washes cars away like toys. I don't know if we'll see it here, but boats flow over that wall like miniatures. Now, so again, tsunami is a scale-independent term. The fact is the Japanese have been encountering tsunamis as a result of earthquakes for, I believe it would be thousands of years. And they have a tradition of stones that they actually put in the hillside that says, don't build below this stone, because we know tsunamis get at least this high. The modern Japanese have built below a lot of those things. In fact, they built a nuclear reactor below those stones and paid the price for it. We all paid the price for it. But something about the way the water flows in some of the videos we've seen out of Tibet and Nepal looks more tsunami-like than anything else. But tsunami is not a mountain phenomenon. So,
so the most interesting part of this is not the words at all.
Yep.
So, maybe it's just not worth going here, but I was surprised that you didn't feel like this was really a flash flood, because it feels like exactly a flash flood. And I'm also surprised that you would use the word tsunami for what has just happened in Nepal
Not
and
a place.
Tibet. No, not a place at all, in Nepal and Tibet. And I have not looked it up. I don't know what the official definition of tsunami is. But just like for me, flash flood refers to what happens when there is so much water suddenly that is overflowing a watershed, regardless of what caused it. Whereas tsunami feels to me like it's a word that specifies tidal water that is in an amount that is more than expected. But that I don't think tsunami applies to a freshwater system.
Well, actually, it does. I'm trying to remember the details of it, but tsunamis have multiple.
How about a riverine versus a why can't I think of the limnological word, like a lake system?
I'm not. It's going to be very unlikely in a river, but I'm not convinced that there aren't cases where a river becomes a lake, in which it was possible. But basically, you have a couple of different tsunamis, and probably they should have a different term. And I'm sure inside of whatever science it is, hydrology or geology or whatever it is where these things are studied, there, I'm sure, are all of the gradations that you would want. But a tsunami is typically, or most commonly, the result of a oceanic displacement of the seafloor that causes water, which cannot be compressed, to move. A wave of energy in the water moves that causes first the sea to recede and then to rush back in farther than it would normally go. And it's the farther than it would normally go that looks tsunami-like in the mountains here. But there's a kind of tsunami that can happen in a lake, and there are some famous examples, including ones in relatively modern times where people live to tell the tale. Some of the worst tsunamis actually are in these lake systems because they're very confined.
Yep.
And what happens is a mudslide on one side displaces a huge amount of water and can put a wave up the other side that's hundreds of feet tall.
Yeah, so I'll say that as I said it, I knew that freshwater was the wrong description, but I think it's still water, it's flat water versus running water.
Yep.
That I don't think tsunami gets applied to riverine systems.
Yep. I think it doesn't.
Because there's directional flow.
Yep.
Right? Although, maybe in something, a tidal river like the Thames, then you have some borders that are very fuzzy indeed.
Yeah. Tidal river or a dammed river is going to mean that you have lakes where you
effectively you do have lakes there.
Yeah. But yeah, I'm not attached to the terminology. My feeling is just, I'm looking at something I've never seen before.
With what just happened in Nepal and Tibet.
Right. Mm-hmm. And I'm trying to draw on all of the places that have something to tell me about what happened. And tsunami is one of them. Flash flood is one of them. The great Missoula floods are another.
And part of what you're doing, I think, is trying to imagine if 200 years from now you came upon whatever this is going to leave in terms of evidence. What kind of story, what kind of scientific story do you think you could put together based on what it has left? And how accurate do you think you could be, given that this particular confluence of events is relatively rare in our experience?
Yep.
In our scientific experience in terms of like what we understand to happen.
And, I guess the point is the rarer an event, the more difficult your job in piecing together what it was if you don't have the immediate evidence. And so something like a lahar, where the heat, this is my understanding, you geologists can take me to task, but the heat of a volcanic eruption takes a sufficiently tall volcano that it has glaciers on it and melts the snow suddenly, causing mudslides. This is something that happens enough that we have lots of cases around the world. We have lots of modern evidence of these things happening, video of it occurring. And so the point is we have a very complete story about that. But if it was a rare event, then you might have one and you might puzzle over what happened here, right? Was there a particularly anomalous year of rain that caused a bunch of saturated earth to break loose and flow down these watersheds as if it were water itself? So, that belongs on the list. And then the sort of final piece of this, I didn't know this, but there is a prior case in our lifetimes, just barely, 1970. There was a case in Peru of what's described as a debris avalanche. So typically, avalanche technically means snow. So a rock slide is not an avalanche, even though we imprecisely will use that term for it. But what happened in Peru...
So why would you ever call something a debris avalanche rather than a rock slide?
See,
given that we have a word for it. I can't back on the semantics, but I feel like when there is a word for something, why... it's not quite a portmanteau, but like, why combine other terms when you already have a word for a thing?
I think because what we're really seeing is that we live on a highly dynamic planet, and all of the intermediates happen occasionally.
Sure.
And so what we have is a tendency, to categorize things for our own purposes, and then the thing that fits between categories emerges, and it forces us to push it one way or the other, or hyphenate or something.
Yeah, no, obviously I'm well familiar with that. I just don't... Tell us about the debris avalanche, because so far all I've heard is it was effectively a rock slide.
Can you put up the image from Peru? You had it up earlier, the one with the so here is the one image. So here what we have is an incident in modern times, but early enough that we don't have, nobody had a cell phone in 1970. So, and do you have the Wikipedia entry that describes what took place here? Can you scroll down?
The Huascarán debris avalanche.
Yes, 1970.
Never heard of this.
Yeah, I had not either. You want to start reading?
The 1970 Huascarán debris avalanche occurred on May 31st, 1970, when a debris avalanche and mud flow triggered by the Ancash earthquake destroyed the town of Yungay, Peru, and 10 nearby villages, leaving up to 30,000 people dead. It is the deadliest avalanche or glacier-related disaster in history, surpassing the death toll from the previous deadliest avalanche disaster, the avalanches of White Friday on the Italian front of World War I, and the third or fourth most deadly landslide-related disaster of the 20th century, after the Haiyan landslides in China, the Armero tragedy in Colombia, and by some estimates, the Kite landslide in Tajikistan. I'm going to keep going?
Yeah.
The North Peak of Huascarán, from which the avalanche originated, had been considered unstable since 1962, so for 8 years, when a smaller collapse wiped out several villages of the Callejón de Huaylas Valley near Yungay. I have no idea how to pronounce any of these words. However, the provincial government made efforts to prevent the news from spreading and urged people not to panic. The 1970 earthquake destabilized a glacier and snow mass, which surged rapidly downhill, becoming a mud flow as it accumulated large volumes of loose dirt, rock, and surface water. There it is. That's the
answer.
Is it avalanche? Is it rock slide? It's both. The death toll was made worse due to the earthquake having occurred on a Sunday, as thousands more people had congregated in Yungay for a market when the mud flow struck and leveled the city. The slide then entered the Rio Santa and caused extensive damage as it flowed all the way downstream to the Pacific Ocean, a distance of 100 miles, mostly through a narrow canyon.
Yeah. So the answer is technically it's got some avalanche in it.
Yep.
It's got a destabilized glacier. And
Yep.
So anyway, I still think the point is a lahar is caused by the glacier above that you're not thinking of. The
Huascarán
debris avalanche is caused by the destabilized glacier above. What we're seeing in Tibet and Nepal is the destabilized glacier above. You know, that's not weather. Flash flood is caused by weather typically. Sometimes it does have this characteristic where it creates a debris dam that then bursts and causes the flood to be much more intense and sudden. So all of these things blend together. But I guess
So there's a question not just, but about like evidence and how we understand what is true, but also about categories. And presumably being limited by our own existing categories in terms of what then we can interpret about the world.
Yeah. And, you know, I think I knew barely what a tsunami was in 2004 before the Boxing Day tsunami in Asia. I didn't have a real good grasp on it.
I was obsessed with them as a child, but I still misunderstood them. I was terrified of them.
Yeah.
But I wildly misunderstood what they usually looked like.
Right. And, you know, nothing competes with the first one of these major tsunamis that happens while people have ubiquitous phones that can take video.
Yeah.
So we saw stuff from all over the place. You know, I collected a bunch of those videos because what you could learn about what the Earth can sometimes do was tremendous. So, you know, there was that. There was also the ability to, you know, as the term tsunami registered globe-wide with billions of people who, like me, did not have a good grasp on what it was, we changed. Our culture got upgraded globally all of a sudden, like within 24 hours. And also circulating along with it, I don't know if you remember the models in the best sense of the term that I don't even know which branch of science it would be, but basically wave theory was used to show, all right, here's the epicenter of the earthquake. Here's how much water we think was displaced.
The in real time predictions about when the waves are going to hit and where and about how high they will be.
Right. And so basically just as if they were sound waves and this was a giant canyon of buildings where the sound is ricocheting off of buildings, losing energy as it does, it misses this place entirely because this place is in the shadow of that island.
Right.
You know, so we could see these waves pushing the energy around, and places that you wouldn't have thought would have been devastated were, and places that you would have thought would be devastated weren't. So the educational upgrade that came from both the tools, the modeling tools, the photo and video tools, and the communication tools, like humanity got a cultural upgrade that was nearly universal. If you were plugged into the internet, you learned all this stuff all at once. So that's a unique thing that is unlike prior eras.
Yeah. I don't have it prepped here now, but on a future episode, maybe we should show there's some remarkable, terrifying educational models of what will happen in the part of the world where we live if the big one hits. That is to say, if the giant fault off of the Pacific Northwest that runs north-south from sort of off the Oregon coast up through the Washington coast, up off of Vancouver Island, rifts, and what the tsunami that will come in as the Pacific Ocean surges into the Salish Sea will do to this island archipelago where we live is extraordinary. And it's one of these things that you can watch on repeat. You know, like, okay, so how much, like, oh, you have more time than you think. And then once you have no time, you have no time at all.
Yep. Yeah. Yeah, those models are quite something. All right, I think that's all I've got on this topic, and it of course connects to your first topic, because we are talking about a question of historical evidence and what basically the short version of the historical evidence issue is that history is unkind, in that it destroys much of what you would like to have in order to do any analysis. So evolutionary history is exactly such a science. It'd be lovely if we had every creature in every fossil form, intermediate fossil form, but we don't. So we're forced to reason from the fraction of evidence that we have access to.
That's right. That's right. Sorry, I was, we're playing cable games.
Yep.
Jen and I, because my computer doesn't want to show itself. It's very shy. Very, very shy. Okay, so let me just start with this article published April of this year in Theoretical and Applied Climatology by John R. Christie, titled Declines in Hot and Cold Daily Temperature Extremes in the Conterminous U.S. 1899 to 2025. Conterminous is a term like contiguous, but not exactly the same, apparently. And I don't know, since we're playing semantic games today, I was interested to hear that the reason that contiguous is often not preferred is that you could argue that Alaska is contiguous, it's just not continuously contiguous, whereas conterminous refers to a land mass that shares a single perimeter. And so conterminous is also, it's lower 48. Okay.
So we are excluded from the conterminous United States.
I suppose actually we are, yes, being on an island that may get wiped out when the big one hits. Yes. Okay, so again, declines in hot and cold daily temperature extremes in the lower 48, 1899 to 2025. I came across this article because the Epoch Times did an interview and a piece with the author, John Christie, about this research, and that's mostly what I want to read from. But first, just a few things from the article itself. The abstract, he's talking about having looked into the database that also is what NOAA uses, NOAA being the National Oceanic and Atmospheric Administration, I think is what all those letters stand for. And just a few things that he notes in the abstract, the author, the researcher here. The original 1,218 stations selected in the 1980s by NOAA as capable of addressing climate concerns have since been neglected. Almost half of the stations have closed since 2000. So right there, we've got like a strange observation that I didn't know, that like we're continuing to get these NOAA assessments of what's going on with climate, but they are dropping these weather stations like flies. And there's no explanation. Well, there's some explanation for some of them, but not across the board.
So one question that arises for me right away is how random. If they are closed at random, then it's bad, but not catastrophic.
Right.
If they are closed in a way that's non-random with respect to temperature data.
And I don't think it's specific to temperature data, but I think Christie, for instance, probably knows a lot more than I do. I don't think that the entire story is known, but I don't know on what basis those decisions have been made. The end of his abstract is, in some instances of both hot and cold extreme metrics have declined since 1899. Okay, so that is what he finds. And again, just one more paragraph from his actual article before we go into the Epoch Times review of it. This, again, he's explaining what he's done, which is why he gets a different answer from what we're hearing from things like NOAA and mainstream climate scientists. Now, this is an academic, a working climate scientist, a working academic. So it's not that he isn't part of mainstream climate science, but he's coming up with an answer that looks pretty different from what other people are coming up with. He says all values utilized are actual observed temperatures, bias corrected when needed for merging, without any spatial or temporal interpolation or other types of homogenization methods applied to the station observations. Now, he doesn't say it there, but what is strongly implied by that, if it warrants inclusion in the introduction, is that he is comparing what he has done to what other people do. He is using actual data, and in many cases, he's had to go back and actually recover from handwritten sheets, actual data from these stations from even before NOAA was taking was recovering data, but they were being taken by actual people at these actual places, and he's just using the data as they were taken. And here, let's skip here now. You can keep my screen on to the Epoch Times coverage of this story. Climatologist says a century of weather data contradicts claims of record heat. Despite perception, study indicates a moderation of both hot and cold temperatures in the U.S. over the past century. So I'm going to read the beginning of this because I think it does sort of a more intuitive job than the paper itself of explaining what he's done that's different and why he gets such a different answer from what we're mostly hearing with regard to climate science. American author Mark Twain famously stated, "It ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so." An excellent quotation about the risks of certainty. Likewise, the article continues, digging deeper into data sometimes reveals a different picture from what you saw at first glance. After combing through reports from more than 1,200 weather stations across the United States, former University of Alabama climatologist John Christie is challenging a commonly held belief that extreme high temperatures have become more prevalent. According to his report, which is the paper we were just looking at, published this spring in the academic journal Theoretical and Applied Climatology, the data don't show an increase in extreme temperatures. Rather, they indicate that temperatures have become more moderate over the past century. We have the systematic measurements in the United States that show the extremes of the 1920s, 30s, and 50s in terms of heat were much greater than the ones currently, Christie told the Epoch Times. Even when you include the western parts of the country that are having their 1930s today, the rest of the country is not following the script. On balance, you don't have a countrywide extreme event. Let me pause for a moment and say he is referring to and recognizing that, in fact, in the western states, such as where we live, we are experiencing extremely high temperatures, and it is out of keeping with what has come before, like much of the country experienced, for instance, in the 1930s, which I didn't know before reading this. The National Oceanic and Atmospheric Administration, NOAA, stated that average temperatures have risen by 2 degrees Fahrenheit since 1850, and that this increase has accelerated in recent decades. That's the standard climate line that we hear. According to NOAA, the year 2024 was the warmest year since global records began in 1850, and the 10 warmest years during this period were all occurred during the decade from 2015 to 2024. So this is NOAA's chart. I'll make it just a little smaller if I can. I'm probably going to mess up everything if I try that. Nope, that sort of worked. So the source on this is NOAA, data as of July 2026, global land and ocean average temperature departure, where you had cooler than average temperatures through about 1940, a little bit of a mixture through 1975 or so, and then increasingly hot temperatures, according to NOAA, as they have looked at exactly these same data, kind of, as Christie is looking at. And then you have, well, let me just skip forward for a second and show, and I think there's a typo in this, that this also says source NOAA, but this is actually Christie's analysis. Again, I'm going to go a little bit smaller here. Decline in daily temperature extremes in the contiguous U.S., 1899 to 2025. So this is Christie having gone farther back in time as well, and he intentionally included, and you could argue that maybe he shouldn't have, but he intentionally included this record-breaking, extremely cold year, which I think was like 1890, maybe it was actually 1899. I don't remember. And there's a typo on the far left of the timeline of the graph as well. That should be maybe it does say 1895. I just can't see. But you've got record cold interspersed in time with record hot, with the one extremely cold year beginning his timeline and one extreme record hot year sometime in the 1930s. Okay, so just to go back into the text a little bit here, regarding the cause of, again, this is NOAA's interpretation of these conterminous data stations, conterminous U.S. data stations from 1840-ish.
What's the y-axis there?
The difference from the average.
Difference from the average, but the scale is what?
The difference from the average degrees Celsius.
Degrees. So that is really important to understand.
Yep. And And this is in Christie's graph, we've got the y-axis is the fraction of CONUS with record temperature. So he's looking at extremes, whereas NOAA is looking at averages.
Okay.
And that's they're both coming from the same numbers, but it's what statistically do you do with those numbers, right? And there's nothing fancy here. We're just talking about descriptive statistics. We're talking about, means and extremes, not, not p-values. That's not where we are. We're not in inferential statistics. We're doing descriptive stats here. They are. Regarding the cause of, again, NOAA's graph that shows departures from the mean, not just very, very hot, but getting hotter and hotter all the time, NOAA said that, quote, Earth's average surface temperature has been rising because human-produced greenhouse gases are causing Earth to absorb more energy than it radiates back to space, end quote. Now, I want to point out here that NOAA has combined an observation based on data that they have prepared in a very particular way, and Christie is showing us that you can look at exactly those same data and show a graph that looks very different. But they've also pegged to that conclusion, which, believe it or not, but take the conclusion at face value for the moment. And what they have said is because human-produced greenhouse gases are causing Earth to absorb more energy than it radiates back to space. And even if these are absolutely accurate data, and I believe they are, given what they are measuring, there is nothing in these data that tells us why. Absolutely nothing. Whereas NOAA has made a statement of cause without evidence, at least in terms of these data. However, Epoch Times continues, Christie's study indicates that far from an increase in extreme weather, there has been an overall moderating of temperatures in the United States. In contrast to NOAA's assessment, Christie's analysis indicates fewer extreme high temperatures and extreme low temperatures since 1899. Again, we have this. And he's not saying, I'm showing the same descriptive statistics as NOAA is. He's saying, I went and looked at extremes. But he's also saying, and here we're going to get to this, algorithms and extremes. Given that Christie and NOAA are looking at the same data, how can there be such a large discrepancy? The difference stems from two main factors, Christie said. First, NOAA's chart shows average annual temperatures, while Christie focused on the highest and lowest recorded temperatures during the warmest and coldest seasons. Again, I've already said this, but this is not complicated statistics. This is not inferential statistics. This is just describing the data set as it exists, but describing either means, averages, or showing extremes, the bounds of the population. That's just describing what is. There's no fancy hidden math or algorithms or heuristics. But so NOAA is choosing to show something different from what Christie is choosing to show with what should be the same data set. And so he says, the extremes, he said, are more relevant to climate science because they are setting the, quote, environmental boundaries in which plants and animals live. We could argue about this. I would say they're both relevant, but he's saying we need to see the extremes in order to know actually what's possible and what future biotic changes are likely to happen. The second reason for the different results, Christie said, is that NOAA employs algorithms that eliminate data points it believes could be errors or anomalies. That's critical. Mm-hmm. And this is standard practice in the sciences that use statistics, that use inferential statistics usually. Where that you say, I've got this data set, look at that crazy data point. That's probably an error. I'm going to get rid of the outlier. And sometimes an outlier really is an error and it doesn't belong in the data set. But when you are going through and taking out outliers across the board and then only showing means and then concluding something that runs almost exactly the opposite direction as what would happen if what you were doing was showing extremes, then you have something to answer for. And NOAA has something to answer for here.
So let me just give an example. If you were taking temperature data in Los Angeles in June, and you got a reading of 0 Celsius.
Right.
Then the point is the likelihood that that's a real data point is effectively 0. So you're justified in throwing it out because what it is a bad sensor.
Right.
The problem is once you carve out the license to throw out outliers because they're misinformative, then you have to be an honest person not to use that license to get rid of data points that are inconvenient simply because they're extreme.
Right. And I mean, even putting aside any foul play on the part of the researchers, once you have as part of your just standard wheelhouse, what we do is we throw out outliers, you're in the habit of throwing them out. and they stop being able to inform you at all. You probably don't even know. Probably many of the people at NOAA who are producing the graph that looks so extreme and looks like the conterminous United States are experiencing warmer and warmer and warmer years, not just on the West Coast, but everywhere. They probably don't know, because they are throwing out the very evidence that could inform them and cause them to say, wait a minute, that result doesn't make sense.
Well, they are almost certainly, and we've seen this many times when we've touched on the question of climate, they are almost certainly talking themselves into an understanding by, when they make an error that leans in the direction of their foregone conclusion, they are reinforced into thinking that they are doing the job correctly.
And they are reinforced in that by the granting agencies and the governmental review boards that are encouraging this sort of thinking.
And they would be swiftly punished if anybody did the opposite. So hence why you're reading about this in the Epoch Times.
Right.
I would point out that there is also, I think actually, I'm wrestling with his argument, Christie's argument, that the extremes are more relevant. I think I actually buy it.
I have, because I just began thinking about this in depth, I have left that as an open question in my own head. I don't know. But I definitely don't think that we should default to the mean and assume that that's the only relevant measure.
So let me just make it clear why I think his argument is robust.
So let's just state it again. He is saying that actually looking at extreme, he's just looking at temperature here. Looking at extreme temperatures, not here, but looking at extreme temperatures is more relevant than looking at mean temperatures, because it sets the boundaries of what life can live at a particular spot. That's it. I mean, all we have is a nutshell from the Epoch Times. But That's what he says.
So if you take species A, and species A has a particular temperature above which it dies, then the extreme is actually biologically informative. Yep. Whereas there may well be a mean temperature that, if it, persists long enough, kills that plant, but we don't inherently know where it is. And so the extremes, while it seems like the mean is more informative because it's like, well, what's it generally like? The extremes have greater implication because of the way biological phenomena work.
Yeah, and I think humans, modern Americans at least, but almost all humans on the earth today maybe forget this because we live in comfort. We live in climate-controlled homes where even if you go outside on a particularly hot or particularly cold day and you realize you're not dressed appropriately, or it might not be safe for you given your particular condition to be out there for very long, you go back inside and you forget the visceral experience. And you don't recognize that actually, if it's not safe for you for 20 minutes, it's going to be very hard for a lot of life to survive in that if they don't have a reprieve, they don't have a respite.
Yeah. Go ahead.
Okay, so let's just read a little bit more from this Epoch Times piece on Christie and his recent work that was published a couple months ago. Again, the second reason for the different results, Christie said, is that NOAA employs algorithms that eliminate data points it believes could be errors or anomalies. Christie's research entailed going back to the original reports and collecting the extreme data points that NOAA had removed from its calculations. So again, he's just using the same original data, he's just including more. He's including the stuff that NOAA had excluded. It includes more than a century of weather station reports, from early handwritten notations by the Army Signal Corps and the Weather Bureau to measurements taken by the military and federal agencies today, all of which are collected in a central network managed by NOAA. And here we have pictures of him pointing at a screen. NOAA's figures raised questions and led to more research, Christie said, because some of what NOAA data showed as recent record highs didn't match what he remembered from his own experience. And I love this part of the story because we have a scientist in a type of science that is mostly dealing with such gigantic data sets that you wouldn't expect them to be able to necessarily catch the errors, right? Like field scientists, if we are analyzing data that we took and we come across something that was a typo or the equipment that we're using messed up and gave us a bad result, we can remember back. We have our handwritten notes. We can be like, you know what? It wasn't 20 degrees Fahrenheit in Madagascar that day, because that never happens, right? You just, you know, whereas when you're talking about, climate data across over 100 years, across over 1,000 stations, daily records. Like, there's no way you would expect that an individual researcher to be able to track, wait a minute, that doesn't feel right. And yet he did. He says, when I was going through the federal data that's digitized, I noticed that the government's website says the hottest temperature in Newport, Oregon in history was 94 degrees, says Christy. Christy said, I knew a lot more about the West Coast because I grew up there. So he went back to the original handwritten temperature readings for that site and found not only a reading of 100 degrees in June 1925, but also 10 other days hotter than 94 degrees in Newport. He incorporated those missing numbers and then did the same for other reports from the more than 1,200 stations across the United States. So again, I don't know why I just cut out. To confirm that these extreme temperatures were not an error, Christie cross-checked his findings with other nearby stations to see if they were getting similar readings. This takes a tremendous amount of manual intervention, and that is something we just don't have today because everything's done with AI or a computer algorithm, he said. But without the original data, he said, you can't quite get the true nature of climate and the type of rapid extremes that truly occur. My data set is far more complete than when the federal government provides to scientific researchers. So this turns out to be a story about the necessity and value. Actually, it gets back to the very first thing we were talking about, the value of paper. Right? Like, we still have the original reports that were written on with ink by people over 100 years ago. And if we were just trusting what NOAA was telling us the data were, those would be missing. This is the same reason that museum collections are valuable, that the fact that many universities are putting their museum collections, like their mammal skins and their herbarium collections, far away and letting them fall into disuse and disrepair, and they're ultimately going to get rid of them, is a tragic error because those can't be recovered any more than the original handwritten data sets with regard to weather, which becomes climate over time, can be recovered. So NOAA has a data set that looks complete until it takes a single researcher to say, hold up, I know Newport's been hotter than 94 degrees. I grew up there. Let's go look. And he finds 11 cases of extremely hot weather. And then he applies that same logic, not because he knows firsthand, but because he figures, well, if they did that there, they probably did it everywhere. And in fact, they did. They were excluding the so-called outliers. But what that means is that you get these means. And are NOAA's data correct if you exclude all the outliers? Do things seem to be getting marginally hotter if you're excluding outliers? Yes. And are Christie's data correct if you include all of the data, that we're actually not experiencing more extremes on average, but that there are extremes every year somewhere? Also, yes.
So interesting that eliminating the extremes leaves the impression that it's hotter. There's some underlying story here.
Yes.
So I will remind people about something we've talked about in a number of different topics. The difference between systematic and random error. Mm-hmm. Random error is just noise in your data. A data point can be wrong for lots of reasons, but if they tend to be wrong in the up direction as often as they're wrong in the low direction and equally in degree, then more data will swamp out the noise and you'll be able to see the signal. Right. On the other hand, if you have a systematic bias, like let's say that you didn't throw out the outliers and a failed sensor reads 0, it doesn't max out, it mins out. So your outliers will tend to drag your average down because that's the way the bias in the sensor goes. Mm-hmm. That's a major issue. You can't overcome that with more data because your more data will have the same systematic error. So the question is part of the systematic error here the easiest way to commit fraud in science is to allow the errors that go in the direction of your hypothesis to stand and to purge the errors that go in the direction against your hypothesis.
Absolutely.
And so the concern is that you've got a bunch of cheerleaders for the idea that the climate is warming, and that necessitates all kinds of an infusion of cash into studying how the globe is warming, and B, draconian changes in the way we live. People who like that idea can tell when their study is working in the right direction. And in fact, I would remind people it's a very different topic, but At one point, Aubrey de Grey, who was the researcher who was pushing the idea that human aging was just an engineering problem, that there were 6 causes, and that if we just knocked them off the list one by one, that we would live very, very long periods of time, like thousands of years. It's a wrong argument, but he at one point made a mistake, and he wrote a paper chastising his colleagues for not being publicly optimistic about this idea. His point was pessimism is bad for the discipline. It's going to cause the funding to dry up. So
it's bad for the discipline because it's bad for the funding.
Right. So anyway, he was just a bit too honest there. But
not in general his problem.
Not in general his problem, but in that case it was. But in the case of climate science, where everybody's like, hey, we've got an emergency, we've got to address it, we've got to scare the crap out of people, and we've got to motivate the government to address this because the earth is going to end as a result of human CO2 production. If that's your mindset coming in, then at some level, the work is secondary. And in fact, work that tells the story that you want told, though not valid, though not rigorous, is better than work that tells a story you don't want told that is rigorous, which I think is the story of climate science at the moment. It's got a story it wants to tell us. Oh, and actually, why don't we connect this also to what we're learning about what was taking place inside of the halls of public health during COVID, where their conversations behind the scenes clearly reflect their own doubts at the same time that they are reassuring each other that what they need to do is not express any doubts in public.
Right.
Same phenomenon.
So let me just, it's Christie's long paper, and I want to share a little bit more from it to show how it's done. Like this is clearly, we don't know him, but he is clearly an honest broker. He is not a climate science denier. He is not someone who doesn't think there's anthropogenic climate change. He is not someone who doesn't believe in greenhouse gases. But he correctly points out everything that we've talked about already, that NOAA is using a data set that they have themselves culled intentionally and left with fewer extreme events, that they themselves have let a number of weather stations disappear from their data sets for reasons that we haven't explored here today. I don't know why. And that they have made claims about, given what they have then described with their carefully curated data set, they have then said this is because of the rise of greenhouse gases. And that is a logical inference that is not justified simply on the basis of observations of temperature, right? So here we have on page 16 of this same paper by Christie, published a couple of months ago this year in 2026. Overall, he writes, our project indicates that extremes in summer heat-related metrics for the CONUS, again, that's the coterminous United States, as defined in the 4 questions above, do not show increasing trends, but rather modest negative trends, and thus appear to be substantially affected by other forcings, such as natural variability, in addition to greenhouse gases. GHGs is greenhouse gases. He says, the number of cold extreme events has declined in the past 30 years too. And this is likely in part related to the development of infrastructure around the stations, which disturbs the nocturnal boundary layer, inhibiting the formation of the cold shallow layer in which Tiemann is observed. We've heard that before, right? That the weather stations themselves may be reading warmer because there's urban heat effects, that sort of thing. This, though, additionally, this result, again, the result that he is finding with his data set where he's looking at extremes, not means, of cold extreme events declining in the past 30 years, he says this result may be an early sign of atmospheric warming of the coldest air masses by the added greenhouse gases, though this hypothesis has not been confirmed as a direct result of greenhouse gases. He's acknowledging that that some of what we are seeing, some of what he's seeing in his description of the data by showing extremes that looks like something that we can therefore breathe easier about may actually be an early warning sign that there is heating that is happening that we haven't yet otherwise been able to see. That is how it's done. That is the inference that we should be expecting and hoping for from all of our climate scientists.
Yeah, it's proper self-skepticism and,
Well, I don't even think it's self-skepticism. He's just saying, we see this, Like we see this and that looks fine, but actually that may itself be an early warning sign of something bad.
It's proper caution. And it is the exact inverse of concluding that a temperature rise is definitely the result of the one hypothesis you've got on the table, right? I think the work is de facto fraudulent.
Not his.
No, not his. But the work that he is critiquing is de facto fraudulent, that you have systematic error that is not being pursued rigorously at the very least. So it does not justify any scientific conclusion, because if it's fraud, it's not science. Even if it's just careless, if it's not adhering to a equivalent obligation to purge data that goes for and against the hypothesis, it's not valid. But if the work itself were valid, it would be fair to say that the rise in temperature observed is consistent with the hypothesis that anthropogenic climate change will result from the production of CO2. You could say it's consistent with, but you can't say it's caused by.
That's right.
That would require this to be the theory, and that in order to be the theory, all competing explanations have to have been falsified.
Well, and we have this sort of brute force scientism now that says if we say it often enough and get enough media outlets to repeat it, it becomes the theory. And that, of course, is not how theories evolve. That is not how they were born. In fact, theories aren't born. Theories are the maturity of development of an idea that has to have gone through a lot of trials, and being rammed down the public's throat does not constitute the trials.
No, all credible hypotheses have to have been tested and falsified, leaving one in order to be the theory. And nobody adheres to that, but that's the rules of the philosophy of science.
Yeah. I'm thinking of saving the sex lives of frogs for next time. Just give people something to look forward to.
Absolutely.
Yeah.
I know that they will.
The people?
Yes.
I mean, I think you should. I mean, this is a topic that is strangely near and dear to my heart, because you could describe my dissertation research as about the sex lives of poison frogs. The frogs in question here are not poison frogs, but frogs nonetheless. And
no, they're not tasty.
I doubt they are. I've never, I've tasted a lot of things, and frog is not among them.
Not among them.
And I don't need to.
Yeah.
Yeah. Even though they show up in cuisines across a number of places, but
presumably leaving the animals without their legs in little wheelchairs, and that's just, I don't feel it's right.
No, there's at least one. Is it a Far Side? I feel like they're.
There's a wheelchaired frog thing.
Yeah.
Well, if it's from Gary Larson, I apologize for borrowing your joke, but it was done with love and admiration.
Oh man, yeah, he's the best. All right, so how about this? I promise to start next time with how female frogs are able to choose when the males get super abundant and really raucous.
All right.
Yeah. And check us out on Locals. If you're liking what we're doing here, subscribe to the channel, like it, share it, all of that. And until you see us next time, be good to the ones you love, eat real food, and get outside.
Be well, everyone.